Can we talk about the internet here? Because a lot of people don't know what it is, but most of our day involves interacting with this internet thing. We use it all the time. You're either browsing the web, making payments online, scrolling on your favorite social media, sharing pictures and messages with friends and family. Some of us even have a refrigerator and security cameras connected online thanks to this thing called the Internet of Things. But we don't know what it is or how it works. We're gonna fix that. By the end of this video, you will know what the internet is. What is the difference between the internet and the web? And you will be able to answer a typical web developer interview question, like describe in detail what happens from the moment you type in a URL in your web browser to the moment that web page is visible on your screen. The first thing is understanding what the internet really is. So let's dive in. When you have a bunch of computers connected with each other, you have a network. And when you have a bunch of networks connected with each other, well, you get the internet. In the 60s, projects like ARPANET started connecting the first handful of computers to the network to be able to share resources between remote computers. Of course, back then, all these computers were connected through cables and wires. Wireless connection was not a thing yet. This all started on the west coast of the United States, but soon they expanded to include networks on the east coast, and later, the rest of the world. But how does it work? If you want the short version, here it goes. When you want to send data from one computer to another, your machine sends some sort of virtual envelope through these networks. Inside, you'll find the data you're sending, and on the outside, there will be a set of instructions to tell devices on the network where the envelope is going and how to process the data and information it contains. When the envelope gets to its final destination, the computer that receives it reads the instruction, processes the data, and if needed, sends back a response. If the data is too big, then it is split into multiple envelopes. And the instructions on the outside of each of these envelopes will inform devices, hey, this is envelope 1 out of 5, 2 out of 5, 3 out of 5, so on and so forth. So, if one or a couple of envelopes are missing, let's say envelope number 4 is missing, for example, the server that receives the incomplete data can just ask for that specific envelope instead of having to resend everything again. If you were ever streaming a movie online and the resolution drops, that means a few envelopes were missing. That was the short and oversimplified version, but let's get into the details. There are a lot of different devices connected on a network. For the purpose of this video, we're mostly going to be talking about routers and servers. Routers help data reach their destination by routing the envelope through the correct path. And servers? Well, when we say servers, we can be talking about a server machine, so basically a computer that's connected to a network. Or we could be talking about software that lives in these server machines and can process different types of services. Services are the thing inside the envelope, like emails, videos, data to be stored, and web content. The devices on these networks have protocols and conventions they need to follow in order to be able to communicate with each other. Think of them like rules. Two of these protocols, and the ones we care about right now, are TCP and IP. Let's start with TCP. It stands for Transmission Control Protocol. On the outside of all these virtual envelopes, there has to be some sort of information like a destination field, an origin field, and if the data is too big and it was split into multiple envelopes, we also include that on the outside. TCP sets a convention for how all this information needs to be formatted. The envelope needs to have an exact address of where it is going to and where it is coming from, so the origin and the destination. On the internet, those addresses are called IP addresses. IP stands for Internet Protocol. IP addresses are unique identifiers, and each device on the internet has one. Each of these numbers in between the dots can range from 0 to 255, and with this format you can produce up to 4 billion unique IP addresses. But there are more than 4 billion devices connected to the internet. So people came up with a new version of these identifiers called IP version 6, which allows for a lot more unique IP addresses, like this many. How do servers process the content of the envelope when it is received? Because remember I mentioned that inside the envelope we can put anything, an email, a picture, a video, a call, or web content. All of these are different services. The destination field on the outside of the envelope not only contains the IP address of where it is going to, but it also has a port number. Each service has to reach a specific port in a server. You can think of ports like doors. When the envelope goes through the door specified in the destination field, it will find a server program specialized in that particular type of content. For example, If an envelope contains an email, it has to go through the doors that will lead to the email servers. If another envelope contains web content, it goes through a different door, port 80 or port 443. Those lead to web servers that can process the web content inside the envelope. You might be asking yourself why port 80 and port 443? Well, port 80 is for HTTP and port 443 is for HTTPS. If the data related to the web page is unencrypted, HTTP, it goes through the door or port 80. If it is encrypted and secure, it goes through a different door, port 443, which is becoming the norm. That's why you see on your URL bar at the top of your browser https://www.something-something.com, basically saying, give me the something something website and use an encrypted connection. Another important component in these networks are DNS servers, because when we want to go to a website, we type in the URL bar the specific URL we want to visit, www.google.com or youtube.com or whatever website you visit. But we saw earlier that on the envelope there is an IP address, not a URL. Well, DNS servers are like address books, and you can think of them like lookup tables, matching IP addresses with human-readable URLs, also called fully qualified domains. Now let's pause here and recap, because now we have all the pieces we need. The internet is the infrastructure, the routers, the servers, the cables, and the protocols that allow for all of these things to communicate with each other. And they use some sort of virtual envelopes to move data. And we also know that inside those envelopes we can put anything we want: emails, calls, video, or web content. And it is web content that we care about right now. The web is a service that was built on top of that infrastructure called the internet, and allows web content to be transferred inside those envelopes that we've been talking about. The web works by leveraging two things. The first is the client-server model, and the second is HTTP. The client-server model has your computer, also known as a client, on one end, and a web server on the other. The web server always has to be on and listening for requests from clients. A request like, hey, give me Google's homepage or Facebook's homepage, and the web server sends back a response, something like, I got your request, here's your Facebook homepage for today. And HTTP stands for Hypertext Transfer Protocol, and one of the things it does is enable the communication between a web browser and web server by setting the standard for how these requests and responses are formatted. These requests and responses will look something like this. The first word, get, is the type of request. This one in particular would be an HTTP request of type GET, or commonly known as a GET request. There are other options like POST, PUT, and DELETE. And typically, we use them to signal the web server what we're trying to do. We use GET, for example, when we're trying to read a resource like a web page. Or we could use POST if we're trying to create data on a database, like when we're signing up for a new account on a website. The slash means we're trying to get to the home page, the main page in a domain. HTTP just means the protocol we're using and the version. The host is the exact web server we're trying to access. When the web server receives that request, it sends back a response that would look something like this. We already know what HTTP/1.1 refers to. The 200 is called an HTTP status code. They are sent by the web server in response to a request, and they are meant to give us information about the status of our request. In this case, 200 means everything is okay. Of course, there's more. Have you ever seen a 404 page not found? 404 is an HTTP status code, and it means that the web server couldn't find anything on the URL you're trying to access. And guess what? We can actually peek inside these requests and responses and see what they look like, because it is just text. We can access the developer tools in our browser to inspect what's going on under the hood. Okay, I'm gonna use Google Chrome here, but you can use whatever web browser you want. This tool is available on Firefox, Edge, Safari, Opera, and all the major web browsers. For Google Chrome on Mac, all you have to do is go to the top right corner, click the three dots, then look for more tools, and then a new menu opens, and the last option says developer tools. If we click developer tools, we see this web console. It's called developer console, and it opens up here at the bottom. And the network tab, when you click it, this tab is special because it records all the web traffic happening between your computer and all the web servers it is trying to reach. Now, let's say we want to go to the NewYorkTimes.com, right? When the page opens, It recorded all the files that your web browser had to download in order to be able to render the website you were trying to reach. And one of the first things we see at the top is our request URL. We requested for the NewYorkTimes.com, and we made a get request method, and we see a status code of 200, meaning everything went okay. Now, there's a lot more information here at the bottom that we just don't care about right now, but you can see, if you're curious, you can see and inspect it. If you are more a command line type of person, we're gonna see an example for that too. You can also do this from the command line by using the command curl-I, and then the full URL. If we hit enter, we should be able to see the same information, but just plain text, no tabs, nothing. Here it is. Okay, we learned a lot. We know what the internet is. We know it is different from the web. The internet is the infrastructure, the cables, the servers, the protocols like TCP and IP that enable the communication between devices using some sort of virtual envelopes. You also learned that those envelopes have information on the outside that servers and routers can read to help them get to their destination, and instruction on how to interpret the data inside. And finally, we learned that the web is a service that was built on top of the internet, and using another protocol, HTTP, and a client-server model, your computer can browse the web by sending requests to a web server and receiving responses. If you would like to learn more about technology and the web, remember to subscribe to my channel. And if you're curious about artificial intelligence, for example, if you want to get started with a tutorial on ChatGPT and Midjourney, you can check the video right here for that. Thanks for watching. See you in the next one.